So we're going to be oh, someone's saying something? No, okay. So today we are going to be starting on our third-person shooter in Unity. So kind of humming and hawing about which version we should use. So we're going to be going with the 2020 version, or at least if you don't have that quite yet, whatever latest version of Unity you have installed on your machine. And we're going to be using the URP for our project. So we've been building projects. If we go to new, we're going to be creating a new project for this. We'll go make a new project. We've always created just a standard 3D Unity project. But today we're going to be using the universal render pipeline. And I want to get you guys using this because I'm going to be getting both of your teams using this when you create your projects for team project tomorrow. There's a lot of advantages of using the universal render pipeline. You're not going to notice a lot of differences between the standard Unity renderer and the URP renderer. They are very, very similar. The HD one is actually quite a bit different and harder to work with, but basically the universal render pipeline is a faster running, more efficient kind of version of the standard renderer, but it also has a lot of nice features built in, things like the shader graphs, so we can mess around with cool shaders without having to actually code them ourselves. We get a nice visual editor we can work with. We also get access to post-processing is built in. There are some nicer features for materials, so everything just kind of looks nicer. There's a lot of stuff I almost guarantee you'd want to add to your project that's already going to be in there, which is really nice. So we don't have to go and add that stuff ourselves. So let's go and create a new project. Actually create a new folder. No, that's not what I wanted, VFS. Okay, I'm going to call this the GD59 third-person shooter. And I'll hit create. So if you haven't used 2020 yet, you'll notice there's a fancy new splash screen. They update this every time they come up with a new major version of Unity. And 2020 has some cool new features we'll play with. One of them being the way you work with prefabs is just very slightly different. We'll get to it when we play around with them more later, but the default behavior is you can basically edit prefabs where they sit in the world without having to hop over to that other prefab editor screen. So you can basically edit them what they call in context, which is cool. So you can modify things as they sit in the world and see how it adjusts your scene. It's also got some new cool features. You can right click on things and go to this properties menu and open up multiple little inspectors to compare values on different objects. And there are some new coding features we're going to be using too. So you'll notice when you create both a new URP project and a new HDRP project, it starts off with some sample stuff. You can actually, once that's loaded up, you can actually hit play and check it out. If you right click, you can move the camera around. It comes with a nice little like fly camera that kind of behaves like the normal scene view camera. And we can look around and check out the fancy assets they put in here, little construction scene they set up. And the really impressive part of URP is it actually runs faster than the standard renderer in Unity, but it looks quite a bit nicer, especially with the post-processing stuff built in. Turn off gizmos here. It's very pretty. That being said, the first thing I do whenever I create a URP project is I delete all these example assets unless you're making a game with a construction area in it for some reason. They're not really all that useful to us. So we're going to keep this scene because it's already got post-processing and stuff built in here. So we'll just go and I'm going to, in my scene here, I'm going to delete the example assets just to get that stuff out of my scene. And if you wanted to, just because we don't really need them in the project anymore, at some point we'll be handing this in as an assignment. So they're actually quite large. If we go to the example assets, they are Oh, never mind. I thought they were a lot bigger than that. Only about 16 megs. That's not bad. But I'm going to just, this example assets folder inside assets, I'm going to delete that as well. So we'll bring in our own assets. I believe pretty much everything else we can leave in. I guess tutorial
scripts,
info.
I guess.
We'll leave scripts. I actually don't mind that camera controller for debugging. We'll delete the tutorial info folder as well, because we don't need that. And we can take a look at some of the URP stuff in here. So you'll notice it has a few extra folders by default. Part of it isn't actually part of URP. This presets folder is basically a way you can set up little presets for files when you create new ones. So things like let's look at defaults. So good example is inside the presets defaults folder, this directional light default. So basically this sets up a preset. So when you create a new directional light, rather than using the standard values that are on a camera component, or sorry, a light component, it's going to read these values and use them as the default. So these are handy if you're going through your scene and say adding a lot of lights, just going, plus, and, creating a new light, point light or whatever, you can set up a point light preset and have that basically just dictate what the default for all your point lights are going to be as you add them to the scene. So it's got a bunch of these just standard defaults built in. There's also a folder called settings. So settings is interesting. It contains a bunch of different files that the URP system uses. So as part of the new render pipeline stuff with both URP and HDRP, Unity is pushing more towards making everything asset-based in your project rather than tying settings to your scene, which is really cool. So you'll notice that we have values we can adjust for the specific renderer. We can change kind of how the renderer handles things like the stencil buffer, so we can do weird stuff with having visible characters through walls. It actually has a really cool feature called Add a Render feature. If you go and just Google URP render features, you'll actually find stuff people have added, which is really cool. So this is another great thing about URP. If you want to add something, that'll add an outline around characters or make, allies visible through walls like co-op shooters, people have figured out a lot of that stuff and they've basically just made it free and available online. So you can import the scripts and then add different features to your renderer to turn on different options when you're rendering your scene. There's also a sample scene profile, which is part of the post-processing system. We're going to dig into this more in our programming practical class. We'll spend a while looking at post-processing. If you want to play with it, you can just hit add override and add all sorts of crazy stuff to your project. We've got depth of field. It's really cool, but kind of expensive. You can do stuff. The built-in stuff is bloom, vignette, and tone mapping. So you can kind of adjust the brightness of different lights and the contrast of your scene, as well as add a nice vignette so you get some dark stuff around the edges. It's got motion blur. Panini projection is kind of interesting. Started playing with this recently. So it's basically if you've ever played a game with a really high field of view, like arena shooters like Quake or Unreal or anything like that, they typically have a very high FOV, but it lacks the normal weird stretching around the edges of the screen. If you just make a new Unity first-person shooter and crank up the FOV to like 110 and stand beside a wall, you'll see how the walls will like warp around the edges of the screen and look really weird. Panini projection is actually a post-processing effect that can kind of counteract that. There's a lot of cool options, but we'll kind of ignore that stuff for today. It's also got a couple different defaults if we want to play around with the quality of our renderers. So you could actually expose this stuff on the user end if you're going to set up different quality settings for different machines. By default, it's going to be running on high quality. And you'll find a lot of the same stuff that was normally in the, we go to project settings and you'd have the quality menu. A lot of this stuff would normally be under here, but it's now part of these files, which is cool. So we can have a whole bunch of different quality settings, kind of as many as we want, just listed as different files where we can adjust and tune the renderer to turn things on and off and kind of squeeze out a little bit more performance.
So that's what they basically do in like AAA games, that if you don't have a good enough of a computer, you just use the other
Yeah, so like a big thing would be adjusting shadows, lowering how far away shadows are being rendered so you don't have as many shadows in the scene. It might lower the shadow resolution too. Shadows are a huge performance hit. If your game's not running well, like really poorly in a game, I would recommend hitting your shadows first, turning them to lower off. Might have a big visual difference, but it'll also improve your performance a lot. You can also adjust stuff like the anti-aliasing that's turned on. You can lower that, although that isn't super expensive. Render scale is kind of interesting. I could actually just show that really quick. So this is sort of a newer-ish thing that a lot of games are doing. But with render scale, basically adds as a scaling features. You can increase or decrease the quality of the game with one slider. So if you want to have really crisp images in a game, so right now this is sort of standard render scaling. You can see there's some jaggies on the edge here. You can crank up the render scale, and it's going to be smoother here. So what it's doing at 2 times is it's actually rendering at double the normal resolution and then scaling it down. Then you can go in the opposite direction. Oh, that looks terrible. You could lower it to maybe 0.5. So now it's rendering it at half resolution and scaling it up to fit your screen. So it's going to end up pretty blurry and bad looking, but it's going to run way faster because you're rendering the game at a much lower resolution. Unity actually has a system in place now. I believe it's on the camera somewhere in here, but you can actually allow it to dynamically change the resolution of your game as it's running. So if you are hitting performance problems, you can actually lower the resolution of the game. You might notice this in some games. Some people hate it. I kind of like it. I'd rather things get blurry for a little bit than have like a huge performance hit on my machine.
How expensive is like the blurring thing? Would it be fine to use it for like a background and stuff like that, so it will look far away?
So with render scale, you can't target specific things with it. It's the entire image. For blurring as like a post-processing effect, if you want to like blur a background, that would be, if you look at your post-processing volume here, that would be depth of field, which I believe, oh yeah, is available in URP. So you can turn on depth of field and make adjustments there. It has either Gaussian or bokeh. This is how it adjusts the blur. If you ever played Battlefield, you probably notice when they crank up their depth of field, they have that effect. You can see those like hexagons over top of like bright lights in the background. They always use that in like their box art and stuff. That's basically bokeh filtering. And this is incredibly expensive. This is another big one to turn off if you are having performance problems in a game. It looks super cool because you can have nice like sharp images up close and then the background will be nicely blurred out. But it can be very expensive. Okay, so for today, what we're going to work on is, if Moodle was working, we would see class 1 is all about character movement and class 2 is about camera. Those are kind of linked, so we're going to hop back and forth between both a little bit. But I'm going to swap them around a little. So we work on camera first, just because I find this, particularly in third-person shooters, if we're going to have the character running around, they keep running off screen, it's going to be hard to figure out what's going on. So we'll get our camera set up first, and then we'll start working on character movement. Oh. Sorry about that. Get you back in. Perfect. So basically, we're going to start off with just working on a simple camera controller. And we're going to add a few features to it. It's going to be a customizable camera controller that's going to follow the character, and we'll be able to adjust where it sits vertically and horizontally in relation to the player. So you can do like an over the shoulder or over top of the head. And then we can adjust how far it sits away. And then we'll also add in some stuff so it won't go through walls. So if you back up into a wall, you're not going to clip through geometry. We're going to add in most of the kind of standard camera features. But I'm kind of doing it as a demo. It's a good experience writing your own camera, but I do push a lot of students towards using Cinemachine and Unity now just because of all the features it adds, basically with very little work on your end. So we're going to get basically, 10% of the way through the Cinemachine feature list with our camera. And we'll take a look at Cinemachine probably tomorrow or maybe Friday. So let's start by adding a few things to our scene here. I hope everyone has downloaded that file. I'm going to open it myself here and import it.
What's the downside of using the URP compared to a 3D project? Does it just have more settings?
It's
with it?
a little bit harder to use. The biggest downside would probably be the fact that some assets, you're going to have to rework the materials to get working. It does have an importer. The material setup is just very slightly different because it uses a different shader. They have a thing you can go through and automatically update all the materials in your project to URP, and it kind of works. Sometimes it just completely butchers the material. It's not going to permanently break anything. You just have to go in and manually fix things yourselves. But that's about it. It looks better and it runs faster than the built-in one. So it's a pretty good idea to use it at this point. Still not sure when. At some point in the future, URP is going to replace the built-in renderer. So when you create a new Unity project, it's going to use URP, which is another reason why I want you guys using it. Just kind of future-proofing against that change in the future.
Also, that being said, a majority of projects on the floor, not majority, but a lot of them end up switching to either HDRP or UWRP now,
Yeah.
partway through production. Like I had one that did it after beta, switched to HDRP, and it was fine. Yeah. Being said, try to avoid that.
Yeah, upgrading can be problematic. It's a lot easier to start with either URP or HDRP. Okay, so I hope everyone's got that file downloaded and we can import it. There's a bunch of stuff in here. I have a bunch of humanoid character animations we're going to hook up. There's a character called the Y-Bot. You can see the Y-Bot here. So in this project, we have done sort of full projects with specific art in the past. On this project, I want to focus more on getting game mechanics in and focus more on the kind of prototyping and design phase of things than working on a totally polished, complete project. So we're going with very kind of bare bones assets. So we have the Y-Bot kind of, it's sort of like a knockoff Unreal mannequin character. And then there's also some kind of generic looking weapons with no textures or anything we're going to use for shooting at stuff. And there are some textures we can use for particles and the GUI, and there's also a bunch of sound files that came along with the weapons, so we'll probably hook those up to add some audio. There's also an FBX file for the level, so we can basically dump that in and run around to test both our character, our weapon, and our AI. So we're gonna just import all of this.
Can you remind me how to import it?
Oh yeah, so if you have the file, let me open my window again. So Unity often will break the association between Unity package files and Unity. So just grab the file and just literally drag it into your project. And that should pop open the import dialog. And it looks like we got a random error when it imported. It's probably fine. There is a warning. I made this level asset myself. Where is it? Art, white box, this level asset myself. So you guys, have you guys played around with UVs yet in your art classes? So this has basically auto-generated UVs, and they are absolutely terrible. So we do not want to let Unity, I've actually tested it. Sometimes the UVs are so bad on this file, it will crash Unity. If it does successfully bake the lighting, it looks terrible. So we're not going to be baking any lighting on this scene. We're just going to have to deal with my programmer art for now. But then we've got the rest of the assets imported here. So is anyone not able to import this stuff? Does anyone have problems? If not, I'll assume we're good.
Yeah, I'm just watching, but
Cool.
Teradici, yeah.
Yeah, unfortunately, yeah. I'm monitoring our staff chat to see when things are. Oh, wow. Apparently our IT team is actually checking our fiber lines right now. Doesn't seem to be anything on site. Could actually be a physical connection problem. Hopefully that'll get sorted out soon though. Okay, so we got our assets imported. So let's toss our level in here just to see how it looks. Just gonna double check. Now in 2020, there's actually a button for it, which is kind of cool. So down in the bottom right, you'll see this little light with a thing spinning around it. That is basically telling us that we have auto-generated lighting turned on. So if I throw my level in here, I'm gonna drag this into the scene and just put it at 0, 0, 0. There we go. It's going to look all right. So as long as we don't mark it static for light baking, we're going to be okay. It's not going to look terrible. So we'll avoid that for now. But this will add our level to the scene. So this is a decent little test scene for a third-person character. It's got a bunch of kind of narrow pathways to navigate through. We can test how our camera handles hitting walls and kind of navigating around these little tight corridors. And also one thing just to throw sort of a wrench in our plans, it's got a bit of a ramp, so we can test to see how our character handles moving up and down ramps. One thing we want to do just to make sure that we actually have collision on here, because right now it doesn't have a collider, after dragging the level in, I'm going to go add component and put a mesh collider on it. We don't need a rigid body. We don't need to make any changes. We just have collision on our level now. So even though this is sort of a complex piece of collision, this is going to add colliders to our pillars and the floor and walls. So we're going to have our character landing on it and running around with it. And we'll be able to hit it with our camera to make sure we don't go through walls. Next, let's take a look at tossing our character into the scene. And then we're going to look at setting up our camera controller. So I'm going to go into the characters folder, go into Ybot, and check out Ybot here. If you want to change the color of Ybot, I've got two materials here. If you click on them, you'll find this looks almost exactly like the normal standard Unity shader, other than you see at the top that this one is, it actually says Universal Render Pipeline lit rather than the standard Unity shader. But if you want, you can adjust the colors. Make him, I don't know, make my Ybot green. There we go. And we can toss the Ybot into our scene. Now, for now, what we're going to do is we're going to set up a camera that is going to be kind of independent of our character. And this is the way I like to do cameras. So you could create one massive script that's going to handle our movement and our input and our camera, but I find this always causes issues later down the line. So we're going to spend all this time making a nice feeling camera or character controller that's going to navigate the scene correctly and feel good in our, the scale of our world. And then we're going to go and try and add an AI. And we have this very tightly what we call coupled system where our single script is going to be handling a camera and player input. So if we want to reuse that movement script and put it on our AI, we're going to have to basically reverse engineer it and remove all the camera stuff and all the input stuff. And now we probably have two kind of copies that are of the same script that are doing similar stuff. So what I like to do is I like to create a lot of sort of what we've done before, a lot of generic and reusable scripts that will, so we'll be able to use our movement script on both our character here and on our AI without making any major adjustments to it. So we don't have to keep rewriting the same code over and over again just to get different characters running around our scene. So the first thing we're going to do is write this kind of independently working camera controller. Now, right now, probably notice if we hit play again, oh, camera's down here, we can navigate around the scene, but we have the built-in camera controller working right now, which we don't want fighting with the camera we're going to write. So on the main camera here, I'm going to click that. You scroll down, you'll notice it has this extra script here called the simple camera controller. So this is the built-in one. It's located just in our scripts folder. They just include this in URP and HDRP now, so you can kind of navigate the scene. We're just going to pull that off. So I'm just going to right-click simple camera controller and remove components. We don't need that right now. Oh, a little bit off topic, but I saw there was, oh, right.
Yeah, do you need that? What's the purpose of the universal additional script, actually?
Oh, so that's just a component that the URP system requires. HDRP has the same script. Basically just interfaces the existing camera with the new pipeline renderer stuff. So don't remove that one, just remove the simple camera controller. But yeah, while we're on the topic of kind of writing cameras, I was like just reading that a whole bunch of CSGO team captains have just been banned from playing for like, I think one of them was banned for 2 years because they found a bug with the camera controller in game. So while teams are playing, the team coaches can actually basically get a spectator cam and they can go through different players and sort of give them advice as they're playing. They found a bug where they could detach that from the players and then sit in one spot and basically camp a corner and call out to their team when enemy players were running through it, basically getting an extra player in the world, which is crazy. So the organization is going back through something like 3,000 recordings of games to try and catch people doing this. So yeah, don't write buggy camera controllers. Okay, so we are going to write or create a new script called the third-person camera. Let's go into scripts here and right-click, go create C# script and create the third-person. It's called third-person camera controller. And then we'll open this up in VS Code. So you might notice as you add new versions of Unity, if you go to your preferences, it should keep a lot of the same settings you have set up. So if you have VS Code set up here, it should already be hooked up in the new version. So we can just go right-click, go open C# project, and it will fire up VS Code for us. Oh, it was on my other screen. There we go. I'll open up my third-person camera controller. Okay, so like I mentioned before, this camera controller, basically what we're going to be doing is writing one that is going to follow our character, basically be stuck to the character, but as we move around our mouse or our controller, whatever, it's going to tilt up and down behind the character and rotate left and right around the character. It's going to bump into stuff so we don't clip through geometry. And we'll add some features so we can kind of move it in relation to the character. So you can go over the left shoulder, over the right shoulder, over top, immediately behind, kind of whatever you need to. And like I mentioned, we're going to have it separated from our character in particular. So if you wanted to do something like maybe you were making a third-person arena shooter, you know, like a CSGO style game or like Unreal Tournament, you know, when you die, you get the spectator cam, you can click and go to different people. So this isn't going to be connected to our character in particular. So we could just have a script set up. So when you click, it goes and sets a new target for our camera. So now we're following a new target and we can just hop around that way without having our camera coupled directly to our character controller. we're going to need to set up a few different values here. And we're actually going to use a little attribute on the class we'll add later so we can actually change our inputs and look at how our camera controller here works while the game is running. So let's go and add a few values. So we're going to start off with a header just to keep things organized. I'll call this aim. And we're going to create a vector2 called axis values. So this is going to be where we store our values for our rotation on our horizontal and vertical axes around the character. We're also going to need a section for what we're going to call our anchor. So this is going to be what our camera is attached to. And we'll add, what else will we need here? We're going to need our offset. Maybe worry about that later. Yeah, we'll add that after. So we'll just add our, call this the boom length. The boom length is going to be how far away our camera is from our character. We'll start off at maybe 5 and see how that looks. Okay, so what we're going to do is we're actually going to do this in a separate function. So we've used update and we've used fixed update. There is actually another update we can use. There's one called late update. And this is where I like to do a lot of my camera work. So late update, as the name kind of implies, happens after the other updates. So basically after our update is fired, we've taken our inputs, probably applied input, maybe moved a few things. The physics tick has also happened, so everything's moved using physics. After all that happens, then we're going to move our camera just to make sure there's no weird, basically desync between things moving while we're trying to move our camera. You can often end up with a weird stutter if you have something happening kind of out of order. Maybe the character, moves after the camera does, so it always feels like it's kind of one frame behind. You get this weird stutter. We can avoid that by using late update. And what we're going to do is we're going to use our, minimize this, we're going to use our two values here, our axis values, to adjust where our camera is sitting in the world. But we first need to add a little check. So we're going to stop if anchor is null. We're going to go if anchor equals null, return. Just in case we don't actually have an anchor we're pointing at on our script here, we want to make sure that this component isn't throwing errors as it tries to move to wherever our anchor is and it doesn't exist. Next, we need to find out our anchor position. So this is going to be the point where our we are following on the character. We probably don't want this to necessarily be the root of the character. We probably want to move it kind of up, maybe in a particular direction. We'll add a little bit of functionality to this later. For now, let's just create this value. So vector3 anchor position equals our anchor dot position. We'll adjust this later to add some more features there. Next, we need to go and create a rotation for our camera. So we need to figure out where our camera is going to be facing. So quaternion rotation, and we're going to use, we've used quaternion.look rotation. I think we have used quaternion.euler before. This allows us to create a rotation out of X, Y, and Z values. Now, this is going to be a little bit weird. You would assume that obviously we have an X and Y value from our axis values. We plug those in, but we're kind of flipping them. So our X axis value here is going to be where we sit horizontally as we rotate around the character. And our Y axis value is going to be where we are when we tilt up and down. So we're going to basically swap them around. The first value is going to be our axis values.y. Second value will be our axis values.x. And then our third value, the z, that would be how much we rotate around like this. We probably don't want to make the player sick by having our camera do weird kind of barrel rolls. So that'll just be 0. And now this is kind of the tricky part. We need to figure out where our camera is going to be positioned. So we can use these two values. We can use our anchor position. We know that's where basically we are stuck to. Then we have a rotation. So we can use that rotation to figure out where our camera is going to be sitting in relation to the anchor. So as we adjust our rotation, you can imagine sort of a stick. Right now our anchor position is going to be here. You can imagine a stick coming out of the feet of the player, sticking out like this. And as we rotate, it will kind of go around.
It's going to be like a spring arm?
Yes. Yeah, you guys use spring arm in Unreal?
Not in the class, but I'm familiar with it. Yeah.
Cool. Yeah. So basically like a spring arm in Unreal. So it'll stick out like this. As we adjust our x-axis value, it's going to rotate like this around the character. And then if we adjust our y value, it's going to, this is harder to picture, but you can imagine it's sticking out here. It's going to move up and down around the character like this. So we can use these together. So we can take, we'll call this our, position. Actually, we'll call it the, position works. Position equals, so we can take our anchor position and we want to add, and this is going to be a little bit weird. So we've done this, I believe, once before in Unity 1, but we need to take a rotation and turn it into a vector, into a direction. Does anyone remember how to do that? It's weird. No? Okay, that's all right. So what we want to do is we want to add a direction here. So it's going to be our rotation, and we want to get the back direction out of our rotation. Because if you can imagine our camera, I'm just going to manually move my camera. So say we have a typical kind of third person over the shoulder view, kind of like this. Actually, I'll go right in the middle. So say our view is like this of the character. So our rotation is basically pointing into the screen right now at the character's feet. We want the direction that goes backwards, because that's going to tell us where the camera should be sitting right now. And to do that, we multiply it by a direction. So a quaternion multiplied by a vector returns a vector. The funny thing is, you always learn in math, it doesn't matter, a times b is equal to b times a. In this scenario, that is not true. They're actually different, and the other way will not compile. If you try and multiply a vector by a rotation, you're going to get errors. So it has to be a rotation multiplied by a vector. In this case, our vector is going to be vector3 dot back. So we are getting the back direction out of it. If you wanted to get like the up direction or the right direction out of this rotation, you could just do vector3 dot up or right, and you would get those resulting vectors out of it. And we need to multiply it by our boom length. Comment here. So we'll camera position from anchor and rotation. And the final step here is pretty simple. We need to tell our camera where it's sitting and where it's rotated. So this part is super easy. We're going to go transform.position equals our position
Just to make sure I understand, if you
Yeah.
replace the rotation and the vector back, it would work if you replace them? Like
Yeah,
replace?
so if I do this,
Will it return an error of some kind or
Yeah.
just? Okay.
so you mouse over, it's going to say the multiplication operator cannot be applied to operands of type vector3 and quaternion. If you flip them, you're fine.
Okay.
If you don't remember, I forget all the time and I type them the other way. It's going to error out and tell you.
There's some goofiness I never actually tried. Can you actually pass that vector3 as a vector4 and that'll work then?
I don't know. I've never tried that.
It seems like a really dumb idea. I'm just curious if someone would do it by accident.
Might be able to. It was going to do something very weird, though, I think.
Absolutely. Absolutely would.
Okay.
Boy, I just wanted to mention it, so please don't do that.
Yeah. So the second step is we're going to set our transform.rotation to the rotation value we have found. And that is it for our super simple camera controller. So right now, this is going to be a camera controlled purely in the inspector. We'll add some stuff in a little bit to get input coming from the player. The one thing we're going to add now is this is dangerous. So the only time I really use this is when I'm working with cameras and I want to work in the inspector to see how things are working, because it can be kind of annoying to keep hitting play to test the camera. And in this situation in particular, we don't have input coming from the player yet. So if we want to test this without it, right up above the third-person camera controller class here, I'm going to add an attribute called execute in edit mode. I'm going to add up here, I'm going to say very dangerous.
Shouldn't we use layer following something like that so it will work better?
Sorry?
Shouldn't we use layup for like the camera movement?
We could. If your character did weird like dashes and teleports, I would definitely add some interpolation to the position. For now, this is actually going to feel really good without it. Here, the script will execute not playing the game. So yeah, this can be useful for, like I said, testing the camera. I've used it for some mono behavior components I use for level design purposes, so that they have to execute certain pieces of code as I adjust things in the scene. I've used it, but this execute in edit mode attribute can be kind of dangerous if you forget about it and start hooking things up. So we'll just be aware that it could cause some strange issues. But if we go back to our game here, we can go and put this on our camera and test it out. Oh, you might also notice we're going to start watching the log a lot in this class. You'll notice that we have a couple warnings here. So it says after it finishes compiling that our third-person camera controller, two of the values, the anchor and the axis values, they're never assigned and will always use their default value. So I've mentioned this before, but this is that weird disconnect between the compiler not realizing that we are using Unity and we can change things in the inspector. So if you want to get rid of that, and I recommend doing it because when a warning pops up, you don't want to be in that bad mental state where you see a warning and you go, oh, it's a warning, that's fine, there's nothing wrong with it. It's supposed to be there to warn you that something's up. So if I see that popping up in a script, and it happens very often, you can turn it off per variable, but I'm a little bit lazy. What I like to use is up at the top of the class here, we can add this pragma warning disable 649. So what this does is this pragma is a basically little tag that tells the compiler we're making some sort of change to how it compiles this class. And then we're using the warning disable command to disable a particular warning. In this case, I know this one by heart, this is warning 649, the unassigned value. So that will remove that warning. I've worked at places where we've been really particular about errors and warnings, where you can actually elevate warnings to errors. So if you have a warning, it'll prevent you from playing the game. So we were very careful to make sure we are hiding any and all warnings that weren't really, really important. You'll notice when it compiles again, the warning is now gone. Okay, so I'm going to make sure I maximize on play turned off. And on my main camera, I'm going to add my new third-person camera controller script. Now, by default, it's not going to do anything. We haven't hooked up an anchor yet, so our camera controller is going to do nothing at all. As soon as we plug in our YBot to the anchor, our camera should move. And then we can start adjusting our values. It's going to look, it probably looks very choppy over Zoom. It's honestly, adjusting these values in the inspector makes it kind of choppy. When we're in the game, it's going to feel a lot better. But we can adjust our X and Y values to rotate around the character in both directions. Now you notice we have some issues. First being, we can keep going and just keep going, which we probably don't want coming from the player input. So we'll add the ability to clamp our angle on the Y-axis to make sure we don't flip all the way around the character. And then we're also going to add in another thing to prevent our values from basically going up to ridiculous values. You can imagine if you were playing a single third-person game, maybe in a long mission, you were in there for like an hour, and you were really dumb, and you just sat there holding the stick in one direction. This value, it's going negative right now, but it's going to keep going up and up and up and up. And theoretically, you could hit the floating point limit. Once you get up to like a really high value, it's going to start to get really weird when a floating point imposition kicks in, and your camera's going to start acting really funky. So we're going to add in a check to make sure that our camera also doesn't keep incrementing that value for forever and end up with problems. But we'll add that stuff after the break. I just want to make sure before we go on break, is anyone having issues with this? This should be working for everyone.
Can you show the script again?
Yep.
Yeah, I cannot add my third person camera controller script to the main camera for some reason. So
Make sure your file name and your class name match.
Make sure there's also no errors as well.
Yeah, do you have any errors in your log?
log. Nope, other than just like it says import FBX warning, which isn't really related to the script warning. So
Is your script saved?
yes, it's been saved. Okay. I see what I did wrong. This could be it. And yep, I see what I did wrong. There was a space on my Unity script.
Oh, yeah.
Name, yeah.
So double check that you can add that now.
Yes, I can add it.
Perfect.
It works, yeah.
Are we supposed to be able to rotate the camera, or did you say?
No, it should be rotating even when you're not playing. If you just adjust the X and Y values. If you are currently playing the game, it's not going to do anything.
Oh, okay. Okay,
Yeah.
I see.
We'll have to add our input after. The only way we can adjust the camera right now is just through changing these X and Y values in the inspector. Okay, is everyone else okay?
Could you just leave it on the code screen?
Yes.
While we break? Thanks.
Yep. Okay, so we'll take a break for, let's meet back at 10:15. We'll continue working on our camera, spruce it up a bit, and then hopefully we can get that done in the next chunk. And then the end of the class, we can start working on getting our character movement going. So we still have some features to add. We still need to be able to handle the weird issues of having the camera wrap around too much, and also deal with our inputs coming from the player. So we're going to go and add first our input, so we can actually take some input from the player and handle this in our camera here. So let's go and take a look at some input. Again, just because I want to push you guys into using it, we're going to add the new input system to our project and use that for our input with this camera system. So let's go to Window and open up the Package Manager. You'll notice the Package Manager might look a little bit different in Unity. They are in 2020. They've actually done some weird stuff. If you open up the Asset Store now, actually opens up a tab telling you that basically you have to go online to look at assets. So you hit the search online button, it takes you to the Asset Store website. So it's kind of weird and roundabout now. But to be fair, I never liked navigating the Asset Store in Unity a whole lot in the first place, because it's just an embedded browser that doesn't run very well. So basically what you have to do now is find assets here, you hit a button, and it's gonna open them up in the Package Manager. So basically your packages and your assets will be available in this Package Manager. The nice thing about it is that if you have a lot of assets downloaded, you don't need to go to the Asset Store anymore to grab them again and update them. You can basically do it all through the Package Manager. And you can see I have way too many assets because I only get down to the start of A on my first page. But we'll go with the Unity registry. So if you're not seeing, you might see just the stuff that's added right now. We're going to click this bar at the top and make sure we have the Unity registry selected so we can see everything that Unity has available to us. And we're going to add the input system. So I'm going to click that and hit install. It's going to pop up the end asking us if we want to enable the backend so we can actually use the new input system. If you've already hit yes, that's fine. I'm going to show you guys what I kind of prefer to do. I'm going to hit no. It's going to keep inputting stuff. But there's a third option they don't give you there. If we go to Edit and go to Project Settings and go to Player, down near the bottom, you'll see the section for Active Input Handling. So there are actually three options. There's Input Manager Old, which is the standard stuff, you know, input.getAccess. There's the Input System Package New, which allows us to use the new system. For backwards compatibility reasons, and just in case you want to add in like a quick kind of editor script for testing and you want to use the old version, I like to set it to both. So I'm just going to select the drop down, select both, and then hit apply, and it's going to restart the editor. Yes?
Really quickly, sorry. What do I do about the warning that popped up? Did you say?
Oh, what was the warning you got?
This project is using the new input system package, but the native platform backends for the new input system are not enabled.
Yeah, so I just hit no there, and then I went and set this to both. So if you hit yes, all it does is it sets it to input system package new. But then if you add something from the asset store, maybe that uses the old system, it's going to start throwing errors. So I just like to set it to both, just in case I want to use either one.
Okay.
There's nothing wrong with handling both.
Where are project settings under
So edit project settings.
Ah, okay.
And then
Thank
player, yeah, this drop down there. Yeah, I kind of wish they had the option just when you import it to select both. I don't know why they don't have that available, but. So now we can use the old input system and the new input system at the same time, which is nice. Okay, so what we're going to do next is we're going to set up a player controller. So I've actually kind of knocked this system off after working with Unreal because I really like the way they decouple their controllers. So in Unreal, if you haven't dug around in Blueprint under the hood a lot, they have what they call pawns, which are your player characters running around the scene. And a pawn could be a player, it could be a vehicle.
Quickly before that, it gives me an error, like a red arrow when trying to install the input system.
Oh, which version of Unity are you on?
The one you told us to install.
Oh, okay. What's the error saying?
Resource busy or locked, open.
Interesting.
I can just give you like a photo, it will be easier.
What does it do if you hit clear? Does it stay there?
Clear? No, it's not there, but it didn't install it.
Okay. If you go to the package manager, yeah, the input system, you don't have the check mark. It's not installed.
No, it gives me the ability to install, and now it's like loading.
Okay.
Later.
Yeah, try installing it again. If that doesn't work, I would restart Unity and then try installing it.
It restarted it after I changed it to boot.
Oh, okay. Oh, so it's already, oh, weird. So it didn't install, but asked you to restart?
No, I went to like the edits. It gave me the arrow, and then I went to the edits.
Okay. So is it installing now?
Nope.
It could be, I'm curious, because it seems like it failed to install. Try setting your active input handling back to old, and then try installing the new input system again.
So there's no conflict if you use both systems at the same time?
No, you can read from both as long as you have this set to both.
Oh, I see.
Yeah.
You didn't import samples from the input system, right?
No, I didn't.
Okay.
If you want to dig around more in it, there are, samples available. They have a lot, actually. The really interesting ones are the input recorder. So you can basically record and replay input from the system, which is cool. The rebinding UI is nice. It's sort of an example for allowing your player to rebind input keys.
Cool.
Tom, is it working?
It's restarted.
Okay.
Actually, Quinn, I pressed yes, just a mistake. Or should I have to?
That's totally fine.
Then what about the project setting?
So you can go and adjust that if you want. If you have it set to, if you hit yes, that's totally fine. That's not going to cause any issues for what we're working with. I just wanted to show you guys that there is the option to use both.
Then nothing to do.
No.
The setting. Okay, sure.
No, you're all good.
Thank you.
Okay, it worked, I think.
Worked? Okay. Hopefully. We'll see. Okay. So sorry. As I was saying, in Unreal, they have this idea that you have your pawn, which is your character running around the scene. And then they have a player controller, which they call it possessing. So it possesses like a ghost, that character hops into it and controls it. And then you can depossess at any time. And the character will just sit there doing nothing because there's nothing controlling it. On the AI side, they have AI controllers that can also possess pawns and control them and then hop out. So you can swap them around. You can have a player take over an AI and AI take over a player without any issues. So I kind of like copying a system like that. So we're going to create a separate player controller game object in our scene. So let's go and hit plus, and I'm going to create an empty game object. And I'm going to call it player controller. It doesn't matter where it is in the scene. Right there, that totally works. And then I'm going to hit add component, and just like we did before when we used the new input system, I'm going to add the player input component. Please let me know if you can't add that component for any reason, because it means the input manager didn't install correctly. Okay. Once we have that added, we can create our input actions. So I noticed for a while, this would error out and cause an issue when you hit the button. Then they had it fixed. And then the last time I used it in this version of Unity, it was broken again. So we'll see what happens when we hit the create actions button. But we'll hit create actions. And we already have a settings folder. So I'm just going to put this in the settings folder, and I'll call it, I don't like naming after the project name. I'll just call it standard inputs. You can rename the file after, doesn't matter really what it's called right now. And yeah, it caused an error. So I don't know why Unity does this. It creates the file, but then at the point where it's supposed to plug those input actions into here, it fails. So all we have to do is drag our inputs file into the actions there.
Honestly, failing like this is pretty much expected behavior when it comes to newer stuff. Stuff like this happens all the time.
I don't know
Just
why
get used to it.
But the weirdest thing is that it was fixed for a while. For like in one version of Unity I used, it worked fine. The other option is to hit the little picker button, and it's going to filter out for the file you need. So you can just add it there. And we have our inputs ready to go. And we're not going to adjust anything now because we don't really need to. We've already got move and look set up, so we're just going to use those. It's perfect. Okay, so our player controller has our player inputs set up. And I think I'm going to do a kind of demo of the input system as part of our programming practical class to go further in depth. But we'll use the same system we used before when we used it, where we'll use the basically Unity messages to handle our inputs. So we actually need to create a script now to handle input from our player input here. So I'm going to right click and create a new C# script called player controller. So our player controller is going to bridge the gap, essentially, between our player input component, which is reading input from the player, and send it to our third-person camera controller script. So the way we're going to do this is we're going to read input here. We'll use the, can actually get rid of this. We're going to use that on look function. Remember from before, we always get an input value object. We're going to get, whoops, wait on look. It probably will give us an error on the input value here. So up at the top, we need to import using Unity engine dot input system.
My input actions is like empty. Did you create your input actions and or I'm sorry.
So I use the shortcut here. So if you create a new input actions, it will be empty.
Yeah.
What I did, go none, hit the create actions button here.
Oh, I see. Okay.
Yeah, and hook that one up.
got-
So
I got
that'll
lost.
create it with the defaults, which is nice.
Okay. Thanks.
If you're going to be doing something weird, you don't need any of those. You can create one manually, but this is a nice shortcut for getting things hooked up.
Okay.
Okay. So,
I'm sorry, Quinn. Would you be able to go over how to do that asset? Because like I don't know if I missed it, but I keep on getting like it's just the folder pops up when I hit the create actions.
So you hit create actions,
Yeah.
and then you have to save it. So I saved the settings folder as just standard inputs.input actions.
Okay. And then it just gets
And then
dragged.
it gives an error, so it's not hooked up. So all you have to do now is hit this little button here. Just search for all your input actions and select the one you just created.
Oh, okay. Cool. Thank you.
That'll be hooked up. Yeah.
Thank you.
No problem. Okay, so we're going to read our vector2 input. So we're going to have, as we move our mouse or our thumbstick on our controller, if you're going to test that. So moving left and right with our mouse is going to be our x-axis, and moving up and down with our mouse is going to be our y-axis. And so we're going to save this as a vector2. I'm going to create a private vector2, and I'll call this look input. And all we're going to do in this function is we're going to set our look input as the vector2 value coming from onLook. So that, just a sec, let's go back to the whole chain. In our standard inputs here that we created, by default, it'll add this onLook input, sorry, the look input, which we'll call the onLook function, and give us a vector2, which we are now just saving here. So what I like to do with these controllers is I take the input there and just save it as it adjusts. And then in update, we can go and actually send that value over to our camera controller. The reason I do this is the input system handles controllers in kind of an interesting fashion. With your mouse, you're kind of always moving them, so you have a very consistent input. With a controller, an example, let's see if we can get this open. So if we're doing onLook with our controller, here's my controller here. So we go and we look left, and I move the stick that way. So while the stick is moving, it's going to update the value and call that onLook function. If we have the controller pressed in a particular direction, kind of maxed out, and we don't adjust it, it stops calling onLook. So we don't get any updates. So you can get this weird scenario where it's not sending information even though you kind of are moving the stick. So I just like to make sure I basically cache any value I get from the input, and then I'm going to send that value every frame through update over to my other script. And I do this for like moving, for looking, for any sort of continuous input. Okay, so we need to actually add something to our third-person controller to take inputs from the script, because right now we can't do that. Our third-person controller has no public values or functions, so we need to change that. So what we're going to do, let's open my reference again, third-person camera, perfect. So what we're going to do is we're going to create a function, really simple one. It's going to be called look, and it's going to take a vector2 input value. And we're going to do some kind of fanciness here. So I can't remember, have we gone over the modulo operator yet? Have you guys used that? It's the percentage sign. So you can go 6%7, and that's going to give you the modulo of, 6 modulo 7.
Remainder, right?
Yes. So it is a division that only returns the remainder. That's correct. It sounds weird, but it's incredibly handy once you know it exists. I didn't know about it when I was a student, and I could have saved a lot of grief knowing about it. So basically, I'm going to open up Notepad here. Example. So we have 5 modulo 5. The result is going to be 0. If we go and have 6 modulo 5, the remainder is going to be 1. So it's basically the remainder of our division. We can do this in interesting things with this because I'm turning pink on my camera. That's interesting. We can do stuff like have that input value. So the one on our camera here, our x-axis value, we can take that. Sorry? Yeah.
Nothing relevant. Nothing relevant. I think what's happening is when you have a white stuff on your screen, it looks like the background's bleeding onto you.
Weird, yeah. But with our x-axis value, the float value that's constantly increasing, we can use the modulo operator to basically clamp it between 0 and 360. So we can take whatever value, for example, let's go with, say we're at 360 plus, say we're at 420. Oh, terrible at typing. Modulo 360, the result is going to be 60. So it doesn't matter how high it gets, we can basically always keep it clamped between 0 and 360 to keep it within a normal angle range, which is really handy. So we don't need to do any like take the value, check to see, you know, do a division and check the remainder, or see if it's over 360 and do some sort of math. We can do this all in one line of code, nice and clean. So in our look function here, we're going to go and let's take our, first we'll handle our x-axis values. So we'll use modulo clamp x between 0 and 360. So we'll go axis values.x equals our current axis values.x plus our input.x modulo 360f. So it doesn't matter how much we add or subtract through the input here, we're never going to go outside of that 0 to 360 range. So we have taken care of any weird wrapping issues, get the value getting too high, right through there. Now, the vertical range is going to be a bit different because we don't want to just wrap it between, you know, 0 and a value. We want to make sure it's clamped. So we can't look either too high and like go past looking completely vertical and look behind us because that's going to be weird. And we don't want to be able to do the same thing down because we're going to be looking backwards and our movement's going to get very funky. So we're going to add another vector 2 here. And I'm going to call this the y-axis clamp. And we can actually initialize it here. We'll give it just some values. And I'll say we can look basically between negative 80 and positive 80. So we can look up almost completely straight vertical and almost completely straight down, minus 10 degrees. So we're not going to quite get there. We might have to adjust this in the inspector to kind of get a value we like. So we'll use clamp values to clamp y in acceptable view range. So this is going to look a little bit different. We're going to go axis values.y equals, we're going to go mathf.clamp, which I believe we've used before. This will be our axis values.y plus our input.y, and we're going to clamp it between our y-axis clamp.x and our y-axis clamp.y. So we're taking our existing y-axis value, we're adding whatever our input is, and then we are clamping it between the minimum, which is our y-axis clamp.x. That's currently minus 80. So we can't go below minus 80. And we're going to cap it at the maximum of positive 80, which is our y-axis clamp.y. So now we can't look past that kind of normal viewing range. That makes sense?
Yeah.
Hopefully.
It makes sense.
Cool.
Basically just defining like borders for the values.
Yeah. Give you guys a second to keep writing that down, and then we'll go and we'll hook this up to our player controller. And then we'll have to add in a sensitivity value, because I'm assuming our camera is either going to be really fast or really slow. We'll play around with it to get something that feels decent. Oh, and I think our camera will probably be upside down too, so we're going to adjust that. Okay, am I okay to switch off of this? All right.
I'm good, yeah.
Okay, so in player controller, we now need to take our inputs and apply that to our third-person control or third-person camera controller. So up at the top, we can just drag and drop this in the inspector. I'm going to add a field for our third-person camera controller. And I'll just call this our camera controller. And this is pretty simple. So we are going to call our look function, that public function we wrote, and all we have to pass is our look input. Fairly simple. I believe we've probably used this before, this little operator. Some people call it the Elvis operator. Basically what it does is it's a built-in null check. It's very, very handy. So what it's saying is if our camera controller exists, if it's not null, call this look function and call this value. If for some reason our player controller isn't hooked up to our camera controller, we're not going to throw any errors. It's just not going to control the camera. Just double checking the inputs from this project. Cool. Okay, so we're going to hop back over to Unity. Just double checking chat. No updates from IT yet.
I've been checking.
Oh, so one thing is we're getting that same warning here about the not assigned camera controller. So we could, if we wanted to, add that pragma warning disable 649 up at the top.
To be honest, you probably want to go into your program files and add that to the script execution
Yeah, we could do that.
file. Yeah.
Okay, so now all we have to, go ahead.
Could you I just want to take a look to the third-person camera controller just for a second. Okay, yeah, I have it right. Okay, thank you.
Okay. So now all we have to do is add our player controller underneath our player input and drag our main camera into the camera controller. Now we can hit play. And our camera is going to work, but it's going to be very sensitive. And it's also going to be upside down. So we're going to fix that. But it should be working just as you move the mouse around. If you have a controller hooked up, actually this feels way better. The controller speed feels pretty good. Other than the stick is upside down and messing with me. Okay, is that not working for anyone?
I think I may have missed something in the input, in the player input when I tried to catch up. You change anything though?
On the player input component, your standard inputs or the input file you created should be hooked up.
Yeah, I have to.
If it's missing, just hit the Create Actions button and save that into your settings folder.
I can move my camera with my mouse, but for some reason, the camera also moves like backward. Let's say if there's a stage right below me, it will just zoom past by. I have no idea. Like
Zoom
the camera.
past.
Yeah, I think my camera is also moving for some reason.
Oh,
like
we can take a look at your camera controller. It should be it should be anchored onto your character that you have plugged into it.
So okay, so third person camera should be. So it's not the main camera; it's the player controller. Is it? Can I also share my screen?
Sure. Yeah.
Okay, yeah. I think
Tomer, did you get that hooked up?
Yeah, it was hooked up. I had a different problem.
Oh,
I
okay.
fixed it.
Okay, cool.
So whenever I play it,
yeah,
it just moves.
Oh wait, you might still have the other. You still wait. Select the zoom windows on top, so I can't see your inspector. Third-person camera controller. That is weird. Okay, let's take a look at your third-person camera controller script.
Okay.
So, correct me if I'm wrong, but if we used Cinemachine, we could basically use the camera lag and like other settings with Cinemachine instead of coding it.
Yeah.
Okay.
Anchor position, rotation back times boom length. That looks correct to me. Can you go back to the inspector? So I keep moving this around so I can see different stuff. Click on your main camera.
Camera.
Oh, so your anchor is supposed to be the player. You have it anchored to itself. So it's going to keep trying to move away from itself. That's the problem.
Okay.
Yeah. So select your Y bot.
All right.
Yeah, there we go. Okay, now hit play.
Okay. Okay.
There you go. Perfect. Yeah, that was doing it.
Okay. Thank you so much.
Yeah. Cool. Okay, so let's fix some of the issues we have. It'd be really nice to have a configurable sensitivity. We need to uninvert our y-axis. If you like it that way, I know some people that are nuts play first-person shooters and third-person shooters inverted, so their vertical axis is upside down. You could add an option, basically a tick box, so you could set that in like your player settings when they play your game. We'll just hard code it for now. If you like it the way it is now, you can just leave it, but I'll show you guys how to fix that pretty easily. So we can fix the inversion problem by going up to our, where we create our rotation in late update on our third-person camera controller. I'm just going to put a negative value in front of the axis values.y. And that's going to flip the angle. So we don't have our camera moving kind of the opposite direction from our mouse. The other thing I want to add is a sensitivity value so we can actually adjust how fast our camera moves. Let's add another vector 2 called the sensitivity. And I like kind of a slow camera. So I know just from my prep work, I liked this at 0.1 on both values. But we can adjust this in the inspector. I know some people play with like very, very high sensitivity in games. We'll add that. And then all we need to do is just add these in when we adjust our axis values. So in our sensitivity here, we're going to take this. And where we get our input.x and our input.y, we can add it in there. So our x value is going to be equal to the x, or axis values.x plus input.x times our sensitivity.x. And for the y value, I'm going to go input.y times sensitivity.y. And that's it. So this is going to make it so we can adjust the sensitivity in the inspector. And if you were to add your own control customization to the game, you could have that script adjust the sensitivity value here. Okay, so if we go back to Unity, we can test this out. Just the angle, there we go. And now it's working as expected. If I move my mouse up, I look up, which is nice. And this is the kind of sensitivity I like. If you want to adjust it just over on the inspector here, we can change our y-axis clamp to adjust how much we can look up and down, or the sensitivity if you're finding it too fast or too slow. But one of the problems we're having right now is when we move the camera too far down, we go right through the floor. It's the same thing, as an example, if I were to take my Y-bot here and move him over, say standing right here, I hit play and I rotate around, I'll go right through the wall. Now, depending on your game, you might say, you know what, we're cool with the camera going through the wall. We'll have a fancy shader that will make the wall go invisible so we can still see the player. For a lot of third-person games, rather than doing that, they prefer to add something to the camera so it can detect a wall and stop before it goes through the wall. So we're going to work on that next. We're going to do some ray casting, which I really want to, we're going to do quite a bit of ray casting in this class to really drive it home. It's really important and really valuable in games to know kind of all the different things you can do with ray casting. So what we're going to do is when we move our camera around, we'll send a ray from where our camera's looking towards where the camera's sitting. And if it hits something in the middle, it's going to move the camera to that position. Okay, so we can actually do this with one function. It won't be too bad. But we do need to set up first a mask so we can adjust what we're going to be hitting with the camera. Because obviously, you know, if you have like a chair behind your character and your camera goes through the chair, you probably don't really need to move the camera up if the chair's in the way. Same thing with like other characters. Maybe if it's a really big character, like a boss or something, you don't want the camera going through it. But other small characters, you know, if someone on your team moves in between you and the camera, you probably don't need to adjust the camera distance for every little thing that gets in the way. So we're going to dictate which layers in particular we will hit with our raycast. So let's add some layers. We'll go up to the layer button up here, go to layers, and we'll see the drop down with all the existing layers built in, and we'll hit the edit layers button. We can open up the layers array, and I'm actually going to add a few just to kind of future-proof things. We're going to use a few different layers. We're going to have one for the ground and one for characters as well. So we'll add ground, and then I'll add character. Depending on your game, you might have more for the environment for that, or than that. I often end up with like a ground one and also a wall layer, just so I can tell the difference when like bullets hit, you know, walls or the ground, or, you know, I want the character landing on the ground but not on walls, stuff like that. For now, we'll just stick to these two.
Do you use it for anything other than like raycast?
Yeah, so you can do a lot with layers. You can, on collision, kind of like how we would check for a team, you could put things on different teams. I wouldn't really recommend doing that because there's a finite number of layers. But on collision, you can check between it. You can also, which is really cool, which we haven't done yet, is you can dictate in the editor which layers collide. So if you wanted, you know, you're doing some railgun that can fire through the map, you could put it on a special layer from the rest of the projectile so it doesn't hit walls, it only hits characters.
You can do the same with tags, right? And you don't have like a...
So you can check for, you can filter objects on collision and stuff with tags, but you can't dictate collision the same way.
Yeah, but I'm going to reiterate some of the same thing I said last term, which is if you ever use tags, you have to make sure you hash all those tags. Or like put them into, not hash them, sorry, you just cache all of them, because strings are awful.
Yeah.
So
yeah, strings are pretty bad for performance anytime you're working with them.
Yeah,
I personally, I use the layer system a lot. I don't really use tags a whole lot when I'm working. Okay, so we got our ground and our character layer set up. We can click on our level, and over on the layer drop down, not the one we clicked on before, that shows all the layers, but the one on the inspector when we have our level selected, I'm going to select layer and switch it to ground. So now our level is on the ground layer. Okay, so now we can go into our camera, and we are going to add another little header just to keep things organized. Call this collision. I'll call this the collision mask. So I believe we worked with layer masks before. I think when we set up our 2D character controller in Unity 1, we used a layer mask again for doing raycast and checking for the ground. And it's the same process here, aside from we're working in 3D now and we're checking for walls. So we'll be able to use this. We can check off on our mask and say which layers we want our camera to collide with. Some people hard code layers. I'm really not a fan of that. I'd much rather set up a layer mask so we can adjust that in the inspector, and you don't have to, you know, if someone adds a new layer to the project, you don't need to go in and edit your code to fix your camera. That seems kind of goofy.
What's the difference between using a layer mask and just an integer value?
So that's a good question, because a layer mask, if you mouse over it, actually doesn't say, but under the hood, a layer mask is an int. And it basically, it does some weird stuff to store which layers are in the mask. So it'll convert to an integer, and each layer actually has basically an index. But what it does in a layer mask is it packs them all together into the same integer. So you could work with just an int, but the advantage of a layer mask is in the inspector. If you look at it, we have a collision mask, we have a proper dropdown where we can select all the layers. Basically just adds a special wrapper in the inspector so we can actually check off whichever layers we need. And then the layer mask itself has some additional functionality built into it, which is nice for filtering for specific layers.
Layers are kind of like an integer list, and tags are more of a string list.
So the layers themselves are just an array, essentially, of strings, and those just become layers. So each one, you actually look at it, they have numbers. Our ground layer is 8, so that's its index. But when we create a layer mask, it packs them all together using what we call bit masking, which we haven't played with yet. So bit masking is a little bit complex. The layer mask object here basically just takes care of all that bit masking for us. But under the hood, a layer mask is just an integer, essentially.
You can also use them, like replace the, like give them an integer value, right?
Yeah. Okay, so we're gonna add a new function. Oh, it's after 11 o'clock. Okay, never mind. We're gonna go on a break first. And then we're gonna start working on our new function to figure out where our camera is gonna be based on collision with the world. So let's take a break until, actually, I'm gonna open up both of these just so they're visible while we're on break.
I have a question that is like related to the team project.
Yeah. Sure.
Can I just use like an empty game object as a trigger, just kind of like an Unreal, or is there an easier?
You need some sort of collision on it.
Yeah, but like just use an empty game object with a collision.
Like with no rendering or anything? Yeah, that's totally fine.
Like not an empty game object, like a cube, invisible, make it invisible, and just use it as a trigger.
Yeah, you can do that.
100%.
Yeah. The one requirement is that to have a collision register in Unity, you need either that trigger or the object going through it to have a rigid body.
Yeah.
That's the only requirement. You don't need a rigid body on both.
Yeah, just wanted to know if like it's good to use it or a better way.
No, that's I do that all the time. The one thing I'd recommend doing just for kind of design purposes is actually you can use the layer system for this. So create a layer called trigger or something like that, or volume. Put all of your triggers on that layer and leave their renders on. Give them like a transparent material so you can see them in the world. And then on the camera, go to the
ignore them on the camera.
Yeah, so you don't render them. So you can see them in the level when you're doing all your level design, but they won't render in the game.
That being said, there's actually a default for that as well, built into Pro Tools. When we get to Pro Builder, Pro Builder actually has that already. If you actually select the Pro Builder trigger, it shows in scene and in game view, but not through cameras.
Oh, cool! I didn't know that.
Yeah.
Okay, so we'll go on break for 10 minutes until 11:15. When we get back, we'll keep working on our camera here.
Could you leave the code? Thanks.
Yeah, there you go. Okay, so next step, we are going to be taking a look at preventing our camera from clipping through walls and whatever objects we need it to not clip through. So we are going to write a little function that is going to cast a ray from wherever our anchor is towards the camera and return a point in the middle if it hits it. So we're going to create a new function here. This will be a private function since we're only going to be using that within our third-person controller class. And it's going to be called private vector3 get boom position. And it is going to take 2 parameters that we will plug into it. So it's going to take a vector3 position. So this is our starting point for the ray. And then a vector3 direction, which is going to be the direction of the ray. Whoop, that auto-completed something weird. There we go. And you'll notice after writing this function, we are getting an error. That's because we told it that it is supposed to return a vector3, a position. And we aren't returning anything yet. Once we get the return calls in, it will stop giving us that error. So we are going to use the physics.raycast call. So when we did raycast before, we used physics2d.raycast. In this case, we are just using the normal physics.raycast. So we're going to cast ray from position in direction using boom length. So we're going to go if physics.raycast, and then we're going to pass it a whole bunch of parameters. So we can see them popping up here. So the first thing is the origin. That's our position. The next thing is our direction, which is our direction. Easy enough. Then we have, we're actually not going to be using this particular one. The next parameter is going to be our raycast hit object. So I'm going to go out raycast hit. I'll call this hit. So what this is doing, we've done this once or twice before, but we are in one line here, basically, in the function call, we are creating a raycast hit object, which has a whole bunch of information about whatever we hit with our ray. We are defining it and assigning to it through this function. So if we hit something, we can get stuff like the point out we hit. We'll be able to get the normal direction, so basically the angle of the surface we hit. We can get the reflection off the surface, all kinds of interesting stuff in this raycast hit object. The next parameter is the max distance, so that's easy. That is the boom length. And finally, our layer mask to make sure we are only hitting the correct layers. So the final parameter here is going to be our collision mask. And we wrap the entire thing in an if check. So if we don't hit anything, this code here doesn't execute. It only executes if our ray actually collides with something. If it does collide with something, we are going to return hit.point. So that's the position that the raycast hit. We'll come in here, return position raycast hit. Then we're going to have a little fallback at the end. So we're going to go fallback, return normal position at end of boom. So if we didn't hit anything with the raycast, our camera is just in the air. There was nothing in the way. There was nothing occluding it. So we are going to return our position plus our direction times our boom length. We're basically just doing this calculation again. We're going to replace this with our function call in a minute. So we have two options. We've either hit an object in our world, either a wall, a big character, whatever we want, and we're returning that point, or we haven't hit anything and we are just returning the normal position our boom would be at. The next step is we need to go and take this value from this function, actually call the function and use the value for our position. So all we're going to do is replace the existing check here. So instead our position is going to be equal to our get boom position. We're going to pass it our anchor position, and the direction again is going to be our rotation times vector3 dot back. So that will replace our position entirely with the new position that could be hitting a wall, might not be. That'll take care of any clipping issues we have. Okay, is anyone still copying this down? I think we're good. Cool. So I'm going to hop back to Unity and we can test this out. So if you aren't near a wall, you can just test it against the floor. Before we get it working, though, we need to make sure on our third-person camera controller component here, we need to make sure on the collision mask that we check off ground. If you have it set to nothing, we're basically going to get our normal behavior, which is cool. So if you didn't want your camera doing that, if you wanted it clipping through objects, you could set it to nothing. I'm going to check off ground to make sure that it's going to hit the ground. And there's a little bit of funkiness there. One of the issues is that our camera is focused right at the character's feet. We're going to fix that in a minute, so it won't be right against the feet. So we basically end up in this position where we're completely parallel with the floor, which is a little bit awkward. So we'll fix that. But when I move past the wall, getting a nice effect of the camera not moving through the wall. Okay, so the last little thing we're going to add to our camera here is our local offset. So we're going to add a value here. Underneath the anchor, I'm going to add a new vector 3 called offset. We don't even need to initialize it. We'll adjust it in the inspector.
It's not working for me. Like,
oh, it's not working?
Yeah. I think it's something with the direction, maybe.
Is your level on the ground layer?
Yeah.
And has a mesh collider?
We needed to edit, so it's like.
Yeah, you need a mesh collider on your level.
Oh, yeah, it has a mesh collider.
Okay.
Mesh renderer.
Yeah, it should have a mesh renderer and a mesh collider component.
Okay.
So sorry, was it missing the collider?
Yeah, it was missing the collider.
Okay, that should take care of it.
Now it just breaks like the ground, but it's not moving there.
It's not moving? Oh, the ground's going to be a little bit weird right now.
Yeah.
Try testing it against a wall.
Yeah, it's fine.
I just remember too, I totally forgot. There's a new, I guess it's been in Unity for a little while now, but there is a feature. So if you notice when you hit play, there's like a little bit of a delay before it starts. As your project gets more complex, that delay will increase. They actually have an option now. If we go to edit, go to project settings, and then editor. They have this option down very close to the bottom that says enter play mode options. This basically turns off a whole bunch of the normal operations Unity does as you enter your play mode, and will speed up basically how fast you can enter and exit play mode, which is really cool. So if you just check off this, if you go to project settings, editor, and check off enter play mode options, you can just enter play mode a lot faster. This is actually new in 2022, the section down below. You can change how Unity will label and number things when you create duplicates, which is really cool. I'm not a big fan of the parentheses. You can change it to like underscores or a dot. And you can even change it so you can have a particular number of digits. So you could add 3 digits, so it'll count up to like 1,000. It's really nice.
What settings do you have on your main camera?
Right now, these are my settings. Is yours not working correctly?
No.
What's wrong with it?
That's a good question. I'm trying to figure that out.
What about the movement system?
Yeah, well, what behavior is not working?
There is no movement anymore.
Okay, so it just doesn't move at all.
Is there any errors?
What happens when you adjust your x-axis value? Does it rotate?
No.
Do you still have the execute and editor mode on the script?
Yes.
Okay.
I might have forgotten something.
There's no errors, correct? Like there's nothing red underlined, nothing in the console.
No.
Okay.
Was it working before we added the get boom position?
Yeah.
Okay, so there's probably something wrong there.
Where did it start from? Like I had the camera start from below the ground, so maybe that's what makes it stuck.
No, my camera's above the ground.
I would double check that your code looks like this.
Yeah, that's what I'm just doing really quickly.
Also make sure that the call on your get boom position is correct. You're passing the anchor position and then the rotation times vector3 dot back.
Yeah, that one's fine too. Could you go up a little bit, please?
Yep.
You have the second return as well.
How do you get it to do the SPF thing again? Was that something we had to set up?
Oh yeah. You know what? Let's do it after class. I'll send you the file and show you how to add that again.
That's fine.
Oh, it's currently on Moodle. I can send you a copy of mine off my machine.
Okay.
I'll check and see if that's back up. Actually, I haven't checked it.
I'm gonna see if maybe. I'm still nothing.
Well, nothing. Can you share your screen?
I can try. Oh wait, that's a bad idea. I should have done this the window.
No. Sharing the window does some weird stuff with Unity.
Oh, okay.
Just like I gotta minimize these because there's so much stuff in the way. Okay, looks like your anchor is missing. So you need to plug your YBot into your anchor. You see it says non-transform? Yeah. So select the YBot.
Yeah, there it is.
There you go.
Okay. Yep, there we are.
That got disconnected somehow.
Neat. Thank you.
No problem. Okay. Okay, so we've got that working. The next step is to add this little local offset. Because we want to move the camera up. Because right now we're staring at the player's feet, which is kind of weird. And it's also directly right down the middle of the character. We probably want to be able to adjust that kind of left and right. So we've got our offset value in here. What we're going to do is we are going to modify our anchor position with that offset value. So we're going to go anchor dot position. I always need to look this up because I always use the wrong function. Okay, so we're going to add, we're going to go anchor.position plus transform dot, and we're going to use transform direction. Is it going to give us a, tell us what it does? There we go. So we mouse over it. Transform direction transforms a direction from local space to world space. So our offset is going to be in local space because we want to adjust relative to the player up, down, and left and right, and forwards and back on our offset. So we have to use this transform direction to take that from local space to world space for the positioning of our camera. All we have to do here is pass our offset value into the transform direction value there. If you need to go the other way at some point, which probably will come up, there's also an inverse transform direction, which will take a value from world to local, which is handy. Okay, so let's test this out. So if we adjust our X value, camera is going to move left and right. Oh, sorry, I just realized I totally messed that up. We don't want to go off of our, because you can see right now the effect. This is using the local position of our camera based on the camera position. We don't want that. It needs to be based on our anchor. So we want to go anchor transform direction. Sorry about that. Oh wait, am I losing my mind?
Actually, I have a red line on the offset.
Sorry, I'm being dumb. We do want to use our transform. Oh, but the Y. You know, sorry, I'm going to change my mind. This isn't going to work here. We're going to adjust this. I just realized we want to go the left and right. Yeah, but we need to use a fixed up. Sorry, we're going to change this. We're going to just do the math ourselves. So we're going to adjust first up by going vector3.up times our offset.y. Then we can go left and right by going transform.right times offset.x. If we use the transform direction, we're going to be using the up and down relative to the camera, which is going to be weird because if you think about our camera being sort of in above view of the character, it's going to slide in this direction rather than moving up and down, which is not what we want. Sorry, someone was having an issue?
No, I found it.
Okay, great.
The difference between vector3.up and transform.right is like vector3.up will return +1 and transform right will return the like local position plus.
Yeah, so vector3.up. We could actually go, if we wanted to, we could go anchor.up to get the up of the character. We're assuming just for simplicity's sake that we're not going to be doing any weird changing of orientation and gravity stuff as we move around the world. But we want to make sure that our offset is always vertical compared to the character, but our left and right we want relative to our camera. Just so it, as our character rotates, we don't move that anchor. We want our character to be able to spin freely.
Okay.
Okay, let's test that out. So our offset, if we adjust Y, it's going to move up and down. So our character is, let's see, how tall is our character? I think it's probably like 1.7 meters-ish. So I might have it set at maybe 1, so it's sort of in the middle of the character. And then we can adjust X to go left and right relative to the character. So if I have it at about 0.5, it's going to move a bit to the right. If I hit play, we're always going to have our character centered kind of off to the left of our screen. You could zoom in. Our boom length is pretty high right now. We could zoom in a bit. Kind of adjust these and tune them however we want.
Is the offset the value that we're going to change in game to maybe change the camera?
Yeah, so if you were doing, if you've ever played like Gears of War, they have normally the kind of this angle on your character, but if you sprint, it like moves into that like dude chasing behind him with a camera kind of look where it's really low down. So you could adjust the boom length, really zoom in, and drop the height, and you get more of a kind of down below the character kind of look.
So if I wanted to like in game have like an aim action, we would use the boom length.
Yeah, and you could adjust the boom length. If you're using Cinemachine, which we're going to play with later in the class, there's actually some really cool stuff in that where they have similar kind of setups for third-person follow cameras. But you can actually, rather than having to worry about the boom length and adjust that stuff, you can actually have multiple characters following the camera, each with their own settings. And then you can basically interpolate between the cameras to get the position you want, which is really cool.
Okay.
So you could
like
have
a transition between one camera and another one?
Yeah, and it does it all live. So you could have, if you're going from like that normal state to like the sprint state, you could even like adjust the FOV on the camera to be a bit higher, which makes it feel like you're moving faster. And then have like the chase camera be more shaky. So as you're running along, it's like moving a lot as opposed to the normal zoomed out camera.
So in theory, if I wanted to have a game in which you can switch between first and third person, I could just make a switch between a first person camera and a third person camera?
Yes.
Okay. It wouldn't be the same camera.
So that's kind of depends on how you implement it. In our system right now, we have one camera. And that probably would be how you do it. In Cinemachine, they're smart. They use what they call virtual cameras. So they don't actually have multiple cameras in the scene. They have multiple virtual cameras. And then those virtual cameras dictate where your actual camera is moving between them. So that's the way they set it up. So if you wanted to have a complex camera system you wrote yourself, I might do a bit of a knock off of that. But you could also just have, like you mentioned, have a script controlling the offset and boom length and stuff on this camera here. If you're going to have a complex system like that, though, I would recommend using Cinemachine because it takes care of a lot of that for you.
Okay.
And you could do the kind of transitions. Like if you ever played Overwatch, if you play Reinhardt, normally you're in like first person running around with his hammer, and then you right click to pull out his shield and it moves in the third person. That's super easy to do with Cinemachine.
Nice. Okay. I haven't played Overwatch, but I'll take a look to that.
Will we learn scriptable objects in class or?
Term 4.
Yeah, I believe in term 4 we go over scriptable objects.
Yeah, this term I think we're going to go over like the terror of singletons, and then term 4 will basically show you how to get rid of them.
Because like this will be super easy with scriptable objects, right?
You could have different camera configurations on scriptable objects and kind of interpolate between their settings. So that's one option for it. Okay, so with our offset in, it's feeling pretty good. One thing, we probably want to add, just because it's kind of weird when you get to the point where you're actually trying to test this thing, is we can control the cursor. So I'm going to add a start function here to our camera, and we are going to just make sure the cursor is locked to the screen. So we can go cursor.lockState equals cursor lock mode dot locked. And that is going to lock our cursor. So basically it is going to sit invisible in the center of our screen, the way you would kind of expect if you're playing a shooter style game. While you're testing, it's not going to like keep your camera or your mouse confined forever. You can hit escape and then you'll get access to your camera again or your mouse again. The last time I did this, there is a current bug in this version of Unity where your cursor doesn't disappear. If you make a build to actually demo the game, it seems to work fine, but in the editor, our cursor might still be visible.
Nope, it's not.
No? Okay, so I did see one person mention, apparently, for some reason, this is a bug with the input system. If you have it set to both, or the old system in the editor, it works. If you have it set to just the new system, it'll still be visible. So I'll test it on mine, see what I end up with. Just keeping in mind that it doesn't really matter in the editor. It will work as expected in a build. Yeah, mine's hidden as well. If you hit escape, and get your cursor back. If you click again, it'll hide, which is nice.
If we want, for example, to make the ground not disappear when we like look through it, can we just like reduce the rake by a bit? Like the hit point?
Yeah, so there's a few different ways of doing that. We did a pretty simple implementation. So you could, oh, my cursor was still locked. Even though it's because the camera is, so for now, I just realized that's causing an issue with the camera lock. If I accidentally click here, it locks my camera because my camera script is still working in the editor, which is a little bit weird. So just keep that in mind with the execute and edit mode. So with the get boom position, you could subtract a very small amount from the position to kind of adjust that boom position so it's not in the wall. What I would recommend doing ultimately, if you're going to write a more complex camera system yourself, is rather than a ray cast, you can do a sphere cast, which does kind of what it sounds like. Rather than sending out a perfect pinpoint, it sends out a sphere. You could make it softball sized, and whatever that hits, you get the center of that sphere. So basically that will pull it away from the wall, and it'll also hit smaller objects more reliably. If you have like a fence with really small colliders and you move the camera through it, your camera is going to sit there doing this back and forth as you move around and probably make it kind of awful to play. A larger sphere would make that more smooth by actually not passing.
It works the same as like the raycast, it just throws the ball.
Yeah. There's actually, if you go to the documentation, Unity, physics, they actually have a few different ones. So they have the normal raycast. They have sphere cast. They also have a box cast, so you can fire a box. I've never actually used box cast. Have you used that, Braden? I don't know what box cast is for.
No, I think just sphere cast.
I've used capsule. Capsule cast can be useful. So if you are, say, checking to see if a character can fit through a door, you can just create a capsule the same size as the character and shoot that through the door to test. It's also useful for things like if you're checking to see if a character, if you're working on like a climbing system and you want the character to have enough room onto a surface they can climb up to, you can do a capsule cast up there to make sure that the capsule will fit.
Box cast could work, I guess, if you wanted to kind of do like a box-based puzzle system where you're pushing boxes around and you don't want to have rail-based systems.
Maybe.
Maybe.
That kind of wraps up our camera controller for now. It's feeling half decent, not bad for a little prototype and one day of work. One other thing you could adjust if you want to, since we are playing in third person here, you could adjust just using the Unity editor. So the cameras have a clipping plane option. So if you look at the camera component itself, the clipping planes determine the length at which it'll render stuff. So 1,000 is really far away. It'll render stuff up to 1,000 meters away. If I change it to 10, you can start to see the background there is disappearing. So you can actually have it render less stuff up close. If you ever heard about the development cycle of the first Silent Hill, apparently it wasn't supposed to have all that spooky smoke and fog in the game, but they found they couldn't render the game because everything was basically too high quality. So they started basically lowering their clipping plane. So, you know, they can change it to 10 meters, so nothing past 10 meters is rendered. And then they just covered everything past that with really thick fog, so you couldn't see anything. And suddenly, their game is creepier looking, and It runs better. You can actually do that. Where's lighting? Environment as an example. And crank up. Oh, it's not hitting the background. That's weird. Oh, you could fix that. But yeah, you can add super thick fog to your scene pretty quickly. But I'm gonna leave that 1,000. We can adjust the near clipping plane. So you make that something like 1, and it should. Yeah, you might notice some weird things on the edges of the screen, so maybe not a great fix. Oh yeah, it hits the player even if it's close enough. You can prevent stuff that's close to the screen getting rendered that way, but you'll notice like I can hit the edge of the wall there and it's not rendering stuff, so it's not the greatest fix for that problem.
Sorry, would the clipping plane allow you to see through objects that are really close to the camera? Or
yeah, it basically prevents them from being rendered. If I crank it up a lot, you can actually see they'll start removing stuff from close to the camera. I wouldn't really try and use it for any gameplay purposes. It ends up looking kind of weird. You could do something similar with shaders to get some weird effects though.
would you use that in like a first-person camera just if you didn't want to see your own head? Or
yes, that is a good example. And often in first-person games, it's actually kind of weird. They do this in Unreal, and often Unity first-person shooters do it too. They actually have 2 layers of rendering. So you have your normal, rendering inside your head, and say you put your camera right inside your head. That is a good example. Whoa, come on, wait, let me do this. Assets. There we go. So I'm right inside of his head right now. So you could adjust the clipping plane. If I had the clipping plane at 0, still can't see it. You might see some of the mesh of the head, but they would render the world from that point, and then they would render the gun separately over top, often with a different field of view and rendering settings from the rest of the world. So there's often some pretty weird stuff going on. In Unreal in particular, you can actually see their characters will have 2 copies of their gun held out in front of them, one for other characters to see, and then one for you personally to see when you're in first person. And you can mimic that stuff in Unity too. If you wanted to, it would be a little bit weird, but you could kind of hack this to work as a first-person camera too. If you attached it to the head bone, change the offset, the boom length. Now I'm inside his head.
Can you give something 2 layers like values?
No. One object has 1 layer, which is a bit of a limitation. Luckily, they do have a lot of layers, so you can kind of dictate more layers if you need to do something like that. I know there are some plugins that people have created. I don't know if they're still maintained to add like basically a custom tag and layer system to objects. And you can select multiple layers and tags, but I haven't played with those myself.
Yeah, we can use for like, for example, like player 1, player 2, player 3, and then like make it so only the player 1 won't see Z, for example.
Yeah, you could do something like that.
That being said, with the HDRP and URP, they're adding a new system for like what used to be called camera stacking. If you want certain stuff to be certain ways with certain cameras, there's a new system that I haven't really taken a look at yet, but it's changing entirely how it works.
I think some of that's in already.
It's partially in, not quite. At least for HDRP, I haven't taken a look at URP. HDRP, it's partially in, but not quite fully functional.
You have something really weird with your camera, with your like mic, not camera.
What's going on?
Braden has something really weird with his mic.
Something weird with my mic? I'll open up OBS.
It might just be background noise.
My fan's on. That could be it.
Yeah, I think that's what it is.
So it's
hot.
We only have a few minutes left, so we can't really do much else. But I can show you. You can do overlay cameras in URP, which is cool. So if I wanted to create the world's worst mini map, I could have a camera above my character here that is set to change this to orthographic. You can see it being rendered down here. You make it that big.
And you make it part of the canvas?
So you can make it part of the canvas, or in this case, I'm going to do it super hacky. I'm going to make it just an overlay. And I believe I can, where is that setting now? Base camera. Oh, I think I just need to adjust the, where is that priority?
When you're saying it's hacky, will you actually use it in a game you make, or?
I would for kind of temporary stuff. Oh, I can't change the, oh, weird. Okay, this isn't going to work the way I thought it might. Because I can't change the output on this. Oh yeah, so it looks like the proper way to do it would be what you mentioned. You could render this image out to an image and then put that on your canvas. You can do overlay cameras. I'm just trying to figure out how here. Because you can set up a camera that, for instance, only renders maybe the ground without the character. Might be hard to see over Zoom. But you can see here, I've basically got the same angle, but with no character there. I thought they had an option for, oh, there we go. I'm just blind. It's down here at the stack. Haha. So you can basically stack cameras. So I can add a camera and, oh, there we go. It's already detected it. So the overlay camera. I could do something. That's currently over top of the whole thing. If I change it to render nothing, we're not going to see it at all. I could change it if my character was on the character layer. I could change it so it just renders the character. Now I have second view of my character over top. So you can render objects on top of the existing camera. So if you had another weapon or something like that that only the player should see, you could do that over top of the existing gameplay. Doesn't have post-processing. There we go. So you can do some cool stuff with camera stacking.
Would that be how you add like effects to the character screen? Like if you wanted, I don't know, spiders to crawl across their view? Or...
So that you could do on a camera. You might do that just as a post-processing effect. But yeah, I guess if you wanted to do like animated 3D spiders crawling across it, you might do that as an overlay. Although you could, if you wanted to, literally just do that as part of the existing camera and just have a texture with the spiders on it in front of the camera. Or like kind of like the mini map, you could have a camera rendering spiders, output that to a texture, and then put that on a canvas. You could have that as part of your UI. It would probably be the best option.
Okay.
Okay, so we will wrap things up for today. I'll get a copy of this project. I'm not sure how big it's going to be. I might just throw it on Google Drive if Moodle isn't working in the next hour or two. So hopefully those of you that weren't able to follow along will get a copy of the project. I'm hoping things will be working by tomorrow.
The city cut the lines, so it's up to them.
Wow, nice, perfect. Thanks, City of Vancouver. Tomorrow we're going to be working on our team project. So it's going to be kind of all hands on deck. I'm going to talk for a while about version control. We're going to take a look at Git and GitLab. We're going to get all of our accounts set up and get cracking working with your project so we can start kind of working collaboratively on your team projects.
Next Unity class, are we going to make the character rotate with our input?
Yes. So next class is going to be all about character movement.
Okay.
And then after that, I believe lesson 3 is networking. So we can get some network sync going if we want to try this out online. And then the basically rest of the classes are going to be dedicated to setting up AI. So we're going to get other characters running around and we'll get some guns. We can shoot at them. They can shoot at us. We'll set up some waypoints so they do little patrols and respawn, all that kind of stuff.
Are we using making the AI with NavMesh?
Yes. Well, we're going to hack it a little bit. I'm not a big fan of letting the NavMesh agent control character movement. I like to do everything using physics, so we're going to hijack the NavMesh agent a little bit and then use our character controller, the movement controller we're going to write next class to drive our AI as well.
I remember you also showed me how to add functions to like existing libraries.
Oh, yeah, extension methods.
Will we learn it?
Brayden,
We should, yeah. We do for lists. I think we had an extension method for lists, get random.
I'll add a note, so I'll make sure I bring that up. Because yeah, they are super handy.
Mm-hmm.
Yeah, actually get random from a list would be really cool. So yeah, we can do that.
And also like, if we have time, can you also show like all of us the like the editor tools you showed me?
Yeah, so a bunch of the editor tools that we're going to do are actually going to be covered in the programming practical class. Because some of them, so the first class on Friday, actually, right, I should have brought that up. Thank you for reminding me. The first class on Friday is going to be basically zero programming. It's going to be all about level design. So I'm hoping the people in your class interested in level design, even if they're not in the programming stream, will show up for that. Because I'm going to show you guys how to use a plugin called Pro Builder.
On top of level design, it also covers sculpting in Unity as well.
Yes. So we're going to use this plugin called, might have shown it to you guys before, Pro Builder. Basically is a plugin that used to be a paid asset. Unity bought it, so it's free now. It's just part of the package manager that allows you to basically quickly iterate on levels in Unity. And it's sort of their answer to the BSP system in Unreal. So you can basically just go in and start snapping levels together really quickly, and it does UVs. You could light map all these objects so they look half decent. If you want, you can even apply textures and materials to the surfaces.
That was my next question, but like I asked more about like the customization. You know, what you should be having like the fancy sliders and the
right. So actually, you know what? I'll include that. I would like to cover that in the programming practical class. Do I have that listed? Yeah, I'm going to add that. Yeah, there's a, for anyone out of the loop there, there is a really handy but poorly named package you can install for Unity called Naughty Attributes. But basically, it is an editor extension for Unity that gives us all sorts of cool features for adding basically additional little bells and whistles to the inspector. It's really handy if you are creating components that you'll hand off to designers to use. So we can do things like add things to make sure designers don't break things, or just add little notes to help them out.
2 notes to that. The ultimate version of that is Odin, which is not free. The former instructor, Willie Campos, he actually he took this and redesigned the whole thing from the ground up, and he has that available for free if you want one that's updated more frequently, because this one here has been abandoned, I think.
He's still working.
He's still working? Okay, because the last time I heard, he hasn't updated in a long time.
He hasn't done an official update to the package, but I saw there, actually, I was just looking at it recently. There was like he actually made some commits like 5 days ago.
Oh, okay.
But it allows you to do things like add buttons to the inspector. What else is there? You can add like curve ranges for different values for evaluating stuff. You can add drop-down selections from a list of values. All sorts of cool stuff. You can add your own little flag list, kind of like the layer mask. Oh, it's expandable? Did he add that? I've been waiting for him to add this.
I don't remember that actually being in there. So
Yeah, this is the commit I was looking at, so it looks like it's been added. So this is something for working with scriptable objects, which we mentioned earlier, so you can add a nice little expandable area for them. Yeah, there's a lot of cool stuff. One that's really interesting is the progress bar. So you could add on a health component in the inspector, you could have an actual health bar showing what the current level is. So lots of cool stuff. So we can look at that in the programming practical class.
When is this class?
This is Friday mornings. It should be on your schedule.
Will we go over how levels work? Like if you have 2 levels, how they load in or exist in
simultaneously or separately? Like you talking about stacking levels, like having like sub levels for like the Unreal term would be sub levels for everything. Like what do you mean?
I just mean, how does it work when you have like a volcano stage and maybe a water stage?
Depends.
We can play a bit with that, but it's basically like the way we did it in the previous class when we loaded different scenes. Each level, you could just build into a different scene and then load them when you need them.
Yeah, alternatively, there's 2 different approaches. One is you have a don't destroy unload, which is basically it never destroys itself, and that contains parts of the character. 2, you could have stuff loaded from scratch. 3, in other ways, you actually have one persistent scene that's always there that doesn't get DDOL'd, and then you just simply additively add the levels you want, and then move the character around, stuff like that. There's a lot of ways to approaching it.
I'm not a big fan of those methods. I'm going to show you guys techniques for basically having your game set up so you can load any particular level and just have it work without having to like load from the main menu, then like load up a gameplay scene and add other stuff to it. I'm not a big fan of that. It adds a lot to the kind of testing process and it's very bug prone. So we're going to avoid that.
One scriptable object solve that as well.
Yeah. They're very handy. Okay, so we're already over time, so we're going to wrap it up for today. I'll see you guys tomorrow morning. Your team project is split into 2 sections. I'm not sure if you noticed that on your schedule. In the morning, we're going to be doing coding stuff. We're going to be, basically tomorrow, we're going to be setting up your project. And then the afternoon, you'll be doing audio. And I likely won't fill up the entire 3 hours with instructional stuff each week. I'm hoping to do a bit and then give you guys basically time to work and time for me to kind of work with you guys to get stuff done on your project. So you have a bit of dedicated time each week at least to work on it. So you're not feeling like, you know, okay, it's 6 p.m. class is over. Now I got to work for another 6 hours. I don't want to put you guys under an insane amount of time pressure there. So make sure you guys have a bit of time in class to actually get stuff done.
Thank you.
Yeah.
Do we have any assignments like we need to do?
We'll talk about assignments next class. I'll probably assign first assignment either maybe class 2 or class 3, and then we'll have one more towards the end of the class, which will be adding a major feature to this project. But we'll discuss that more next week.
Cool. Thank you.
Okay. No problem.
Before you end, you have to give Amy needs your code snippets file.
Oh, yes. Thank you. I will send that over.